Look closely at a pristine landscape like this. It is packed with life, water, and minerals. But in its natural state, existing entirely independently of us, none of this is a resource. That word only applies once a threshold is crossed. Elements of nature only become a resource the moment humans apply tools and technology to extract them for our own consumption or sustenance. A tree is part of the environment until we cut it down to build furniture. To cross that threshold, an element has to clear 3 major hurdles. We must possess the technology to access it, the extraction cost must make economic sense, and the practice must be culturally acceptable to society. Once we pull nature across that line, we typically sort these materials into 2 categories. We place coal, oil, and metal ores into a finite box called non-renewable. We place sunlight, wind, and timber into an infinite box called renewable. Categorizing them this way creates a dangerous cognitive trap. We treat the label renewable as a permanent guarantee of unlimited supply. Renewability is not a permanent trait. It is an active, fragile condition. If humans break that condition, the infinite becomes finite. Nature operates on a continuous, mechanical cycle of restoration. Just as a cut on your skin heals over a few days, a forest floor recovers from a severe wildfire, pushing up new saplings and actively rebuilding the soil chemistry over decades. Biologists refer to these inherent processes as ecosystem functions. It is simply nature doing all the hard work of maintaining itself, trees producing oxygen, or plant roots physically filtering water as it moves through the ground. When human economic systems tap into these biological processes for our own direct benefit, like relying on those roots to provide us with clean drinking water, we call them ecosystem services. Maintaining those services comes down to a simple equation of rates. On one side of the equation, you have the slow, steady rhythm of biological regeneration. On the other side, you have the highly variable speed of human extraction. As long as human extraction stays below the natural regeneration rate, the resource remains renewable. The moment our extraction outpaces nature's biological clock, the system breaks. We can observe this mechanical failure right now in the fertile plains of Punjab, India. This region was the cradle of the Green Revolution, producing immense agricultural yields that helped secure the entire country's food supply. To maintain those massive crop yields, farms require immense volumes of water, relying heavily on underground aquifers that were historically abundant. But farms are now pumping water out of the ground at a speed far greater than annual precipitation can naturally refill the water table. Year after year, this creates a massive compounding deficit underground. This map illustrates the depth to the water level across Punjab and Chandigarh as of June 2022. The extensive red zones mapping across the state indicates severe groundwater depletion. Nearly 80% of the entire area is now officially classified as overexploited. By pushing agricultural extraction far beyond the local ecosystem's capacity to regenerate, short-term food security has guaranteed a severe long-term resource crisis. This exact dynamic applies to unevenly distributed resources all over the globe, dictating where human settlements survive and where geopolitical conflicts ignite. It happens through over-extraction, and it happens through pollution. When industries discharge synthetic waste into rivers, they introduce materials that local life forms cannot break down and consume, poisoning the biological restoration cycle itself. Combine this with fossil fuel industrialization and widespread deforestation, and the deficits scale up to macrosystem failures. Today, glaciers in the Himalayas are melting at a rate much faster than new precipitation can replace them, threatening the water security of millions downstream. Solving this requires abandoning the linear economic model of extraction and disposal. Social scientists argue we must design a regenerative economy. This is a system specifically engineered to repurpose used resources, design out waste entirely, and artificially assist in replenishing the environments we draw from. To secure our future, we must align our industrial speed with the innate wisdom of nature herself, the ultimate regenerator of all things.